Hi everyone, welcome to this new video lecture of fluid mechanics. In this lecture, we'll discuss about the properties of fluids. So in the previous lecture, we have discussed about the introduction of fluid mechanics, and in this lecture, we'll continue our discussion regarding the properties of fluids. So the properties of fluids actually categorized into different types. So first one is density, and second one is specific weight or weight density. Third is specific volume, and another one is specific gravity. So let's first discuss about the density of the liquid. So the density of the liquid actually it is defined as the mass per unit volume. So mass per unit volume is nothing but what is the mass of the liquid, that is m, and what is the quantity, the volume of the liquid or fluid. And this density is denoted by a Greek symbol, that is rho. Okay, that is rho. So rho equal to mass by volume, and this unit is actually mass. We know that some quantity of object or some quantity of fluid is there, means that it can be denoted by kg. Okay, it can be that unit of this mass is kg, and volume we know that this is meter cube. So the unit of this density is kg per meter cube. So it is designated by the Greek symbol rho, as I told you, and the unit is kg per meter cube. And the density of the liquid, we know that the heaviest liquid is that is mercury, whose density is very high, and the lightest gas is hydrogen. So heaviest liquid and lightest gas. So this heaviest common liquid is mercury, that density is 13,580, or normally we used to consider it 13,600 kg per meter cube. And hydrogen, how much is there? That is 0.0838 kg per meter cube. And this is lightest one, and this is the heaviest one. And common fluid which we are using actually, that is one water is there, another one is air. So density of water, that is 1000 kg per meter cube. So based on the temperature it will vary, and the density of air equal to 1.23 kg per meter cube. So here I have shown you one density versus temperature plot. If you see here, your y-axis is density and this x-axis is temperature. So this density versus temperature curve, it shows that as the temperature increases, your density of that liquid or fluid is going to decrease. But for water case, it is not that much decreasing. As you can see, if I consider from 10 degree to 30 degree or 40 degree temperature, so the difference of these, you can see 999, suppose here it is there, and almost it came to 992. So there is a less variation in this range if you consider the normal temperature or the standard temperature what we used to follow. So near about it is constant, we can say, but for every liquid is not like that. So density is a function of pressure and temperature, that we can consider. Pressure and temperature is a function of that is density. So this is one unit, one property of the fluid. Second property is specific weight. Specific weight or weight density, actually this is another one property of fluid. It is defined by the weight of the fluid W per unit volume, W by V, that is specific weight or weight density. It is defined as the weight of the fluid per unit volume. Okay, and how to denote this specific weight and weight density? It can be denoted by two things. One is gamma we can take, or we can consider the small w. Both can be mentioned for this. So gamma equal to weight of the liquid by, or weight of the fluid by volume of the fluid. So weight of the fluid, the unit is, we know that Newton, and volume of the volume unit is meter cube. So Newton per meter cube. Okay, so the specific weight we can write in terms of weight by volume in this way. One more is there, we can convert, we can divert this one. Like how we can divert this? Now gamma equal to, in place of W, weight of the body or weight of the fluid, we can write mass into gravity. So mass of the liquid into gravity by volume of the liquid. So this mass by volume we can write what? Density. Just now we have seen mass by volume density. So rho into G. So the specific weight also can be written into rho into G. That's what I have given here. W equal to rho into G. So this is one of the properties of fluids. Similarly, another property is there, that is specific volume. So specific volume, it defines the volume of the fluid by mass of the fluid. Okay, it is the reciprocal of, or you can say reverse of density. Okay, those the specific volume, you can write SV of the fluid equal to volume of the fluid divided by mass of the fluid. So volume of the fluid, we know that the unit is meter cube, and the mass of the fluid, that is kg. So meter cube per kg. Or how we can mention this one in reverse way, if you convert this one like mass by volume, if you want to keep it, so that we can write 1 by mass by volume, that is nothing but rho. Okay, so this is about the specific volume of the fluid. The next category is specific gravity. So specific gravity of the fluid can be calculated in, or can be defined in two different ways. One is for liquid it is different, and for gases it is different. So liquid means, as I told you, like for a fluid it can be defined into categories into two ways. One is liquid, another one is gas. So the fluid categories into two. Let's take an example of for water. So that is coming under the liquids. So how to define this specific gravity of this liquid? Now it is the ratio of density of liquid to the density of water at standard temperature and pressure. Or similarly for gas also. This is one definition. So how to denote this one? S or SG. So we can denote by S, or we can mark it SG. So this equal to, we can write a density of liquid, and second one is the density of water, the standard liquid, you can say. And the standard liquid also need to be considered for its standard temperature and pressure. That standard temperature and pressure, that means at 20 degrees centigrade and 1 atmospheric bar pressure. Okay, so the specific gravity can be identified for any kind of liquid. Suppose I want to calculate the specific gravity of oil. So I can take specific gravity of oil equal to this density of oil. Okay, we need to know the density of oil, how much. Then we know that density of water, so that can be kept here, so that we can calculate the specific gravity of any kind of liquid. This is for liquid case. Similarly, for gas case, you can see specific gravity of gas, that is equal to the wet density or density of gas divided any gas, we can say. If you want to calculate the specific gravity of, suppose, CO2. Okay, so the CO2, you can calculate specific gravity. That means we need to know the density of that CO2, and then we can go for the density of air. Okay, density of air at standard temperature, pressure. Okay, so that we can calculate the specific gravity of any gases. This is one method. This is one method or one definition. Another definition says that it is the ratio of specific weight of the liquid to the specific weight of water. Similarly, or else we can mark it as a specific gravity equal to the specific weight. Just now we have seen the small w or gamma of which one? Any liquid, if you want to calculate. So liquid divided by the standard specific weight of W or gamma of water. So this is the standard liquid what we need to consider. So these are the two methods or two definitions are there by what we can calculate the specific gravity of any kind of fluid. And one example I have given, specific gravity of mercury, that is Sg equal to 13.6. Because in the previous slide we have seen the density of the mercury is given 13,580. Okay, and this is one liquid. So another liquid, water is there, that density of water is 1000. So what you need to do? So we need to calculate specific gravity of, suppose, specific gravity of mercury, how much? So Sg, and this is Hg mercury, equal to density of mercury, how much? 13,000. You can say 580, suppose 580. And what is the density of water? That was considered 998, or you can consider 1000. Okay, based on the temperature and pressure. So here you will get the value of 13.6. So that is the specific gravity of Mercury. So this is what we can calculate, where we can understand the properties of fluid. Apart from these properties, also some other properties or characteristics of fluid also there, like viscosity, surface tension, many more properties are there. But these are the basic fundamental properties of this fluid. So that's why I have discussed in this lecture. I hope you understood what are the properties of fluids, and how to remember this also is very easy. Okay. If you are having any kind of doubt regarding this lecture, you can give a comment on the comment box. Thank you.